Have you ever looked up at the night sky? It is a vast and beautiful place, isn't it? Full of tiny twinkling lights. Most of those lights are stars, much like our own sun, but they are very, very far away. We humans have always been curious about those lights. We have built tools to help us see them more clearly. The James Webb Space Telescope is one of those tools. It is like a giant eye that we have sent into space. It is special because its eye is made of gold, and it can see a kind of light that our own eyes cannot. This light is called infrared light, which is the light of heat. This golden eye floats far from Earth, where it is very cold and very dark. This allows it to see things that are incredibly distant and incredibly old. Think of it like a time machine. When you look at a star, the light from that star has travelled for a very long time to reach you. The Webb telescope can see light that has been travelling for billions of years. This means it can see the universe as it was a very, very long time ago. It can see galaxies being born. It can peer through clouds of dust to watch new stars and planets forming right now. It is a remarkable achievement for humanity. The telescope is made of many small mirrors, all shaped like hexagons that fit together like a honeycomb. These mirrors collect the faint light from distant corners of the cosmos. The bigger the mirror, the more light it can collect. This is just like how a bigger bucket can collect more rainwater than a small one. The Webb's mirror is already very large, bigger than any we have sent into space before. It had to be folded up like a piece of paper to fit inside a rocket, and then it unfolded itself once it was in space. A truly wonderful piece of engineering. But as with all things, we can always imagine, what if? What if we could build something even bigger? Our curiosity is never satisfied, you see. We answer one question and 10 more appear in its place. The Webb telescope has already shown us things we had never dreamed of. It has shown us the atmospheres of planets orbiting other stars. It has given us the clearest pictures of ancient galaxies we have ever seen. So, let us take a small journey of the mind. Let us wonder together what we might see if our golden eye on the universe were to grow even larger. To understand what a bigger telescope could do, we must first understand a simple truth. In astronomy, size matters a great deal. A telescope has two main jobs. The first is to make things look bigger, to magnify them. But perhaps more importantly, its second job is to make faint things look brighter. Most of the things we want to see in the universe are incredibly faint. They are either very far away, or they are just not very bright to begin with. A larger mirror gathers more light, making those faint objects visible, just as opening your curtains wider lets more sunlight into a room. Think of it this way. Imagine you're in a dark forest at night, trying to read a book with only the light of a single candle. It would be very difficult. The letters would be faint and hard to make out. Now imagine you have a second candle. The page becomes brighter, and the letters become a little clearer. A bigger telescope is like adding more and more candles. It gathers all the available light from a distant object and focuses it, making the image brighter and clearer for us to see. This is the power of a large primary mirror like the one on the Webb telescope. But there is another benefit to size. A larger mirror also gives you a sharper image. This is called resolution. It is the difference between seeing a distant car as a single blurry blob of light and being able to see its two individual headlights. A bigger telescope can distinguish smaller details that are closer together. It can separate two stars that are huddled close to one another in the sky. It can see finer details on the surface of a planet or within a swirling nebula. A larger mirror, you see, sharpens our vision of the cosmos. So, when we ask, what if the Webb telescope were bigger? We are really asking two things. What could we see if the universe were a little bit brighter? And what could we see if our view were a little bit sharper? The answers to these questions are quite profound. Even a small increase in size can lead to great leaps in our understanding. It can turn a fuzzy smudge into a detailed galaxy, and a point of light into a world with its own story. It is a quest for clarity, a quest to bring the universe into focus. Let us begin with a modest step. Imagine we could build a telescope with a mirror twice the diameter of the James Webb. This would be a magnificent instrument indeed. It would not collect just twice the light. No, because the area of a circle grows much faster than its width. A mirror twice as wide would have 4 times the area. It would collect 4 times as much light as the current Webb telescope. Suddenly the universe would become 4 times brighter for us. Objects that are currently at the very edge of what Webb can detect would become clear and distinct. With such a telescope, we could begin to study the planets around other stars, the exoplanets, in much greater detail. The current Webb can tell us if certain gases are in the atmosphere of a large, gassy planet. But with a telescope twice the size, we could do this for smaller planets. We could look for planets that are closer in size to our own Earth. We could search their atmospheres for the building blocks of life. We could look for water vapor, for methane, for carbon dioxide. We would be taking our first real steps in searching for habitable worlds beyond our own. We could also look deeper into the dust clouds where stars are born. These stellar nurseries are thick with gas and dust, and they hide the secrets of creation. A telescope twice as big could peer more deeply into these clouds. It could see the very faint heat from smaller, newly forming planets. We might be able to watch planetary systems forming in real time. We could see how planets like Jupiter or Saturn form, and how rocky planets like Earth take shape from the spinning disk of material around a young star. We would be watching the birth of solar systems. And what of the most distant galaxies? The Webb telescope sees them as they were when the universe was just a few 100 million years old. They appear as small reddish smudges. With a telescope twice the size, these smudges would resolve into more definite shapes. We could see if they have spiral arms, like our own Milky Way. We could study the populations of stars within them. We would be able to create a much more detailed map of the early universe, filling in the gaps in our knowledge of how the very first large structures began to form from the darkness. Let us pause for a moment on this idea of seeing the air on other worlds. It is one of the most exciting things we can do with a powerful telescope. When a planet passes in front of its star, a tiny amount of the starlight shines through the planet's atmosphere. By studying that light, we can tell what the atmosphere is made of. The current Webb telescope is already doing this. It is a remarkable thing, but it is very, very difficult. It works best for very large planets like Jupiter that orbit very close to small, dim stars. These are not the most likely places to find life as we know it. Now, imagine our telescope that is twice as big. With its ability to gather 4 times the light, it could perform this same trick on smaller planets. It could look at planets the size of Earth. It could look at them orbiting stars like our own sun. This is the great search. We could analyze the light filtering through the atmosphere of an Earth-sized world and ask, is there oxygen? Is there methane? On Earth, these two gases together are a very strong sign of life. Finding them both in the air of a distant planet would be one of the most profound discoveries in human history. A larger telescope would also allow us to do this for more planets and to do it more quickly. We could survey dozens, perhaps hundreds of nearby rocky worlds. We could begin to understand the diversity of planetary atmospheres. Are most rocky worlds barren, like Mars or Venus, or are atmospheres with clouds and water common? Are there worlds with atmospheres completely different from anything in our solar system? We would move from knowing about a few specific examples to understanding the general rules of how planets and their atmospheres work across the galaxy. It would be the beginning of a new science comparative planetology, and we might find surprises. We look for life as we know it, based on carbon and water. But what if there is another kind of life? What if it produces gases that we have never considered? A more powerful telescope, able to get a clearer signal from a planet's atmosphere, might detect gases that we cannot explain with simple geology. It might reveal a chemical imbalance that points to something strange and wonderful. We would be like explorers landing on a new shore, sampling the air for the very first time, not knowing what we might find. Now, let us take a truly giant leap of the imagination. Let's not stop at a telescope that's just twice the size. What if we could actually build a James Webb Space Telescope that's 100 times bigger? Not in terms of weight, but in its diameter. The mirror would be absolutely enormous, stretching over 0.5 kilometer across. It would be way too large to launch in one piece. Instead, it would have to be built in space, maybe by robots, assembling thousands upon thousands of hexagonal mirrors. This would be, without a doubt, the single greatest engineering project in human history. A true cathedral of science, floating in the void. A mirror 100 times the diameter would have 10,000 times the light-collecting area of the current Webb. That number, 10,000 times, is honestly difficult to even comprehend. The faintest, most distant objects in the universe would shine as brightly as nearby stars do for the current Webb. The entire cosmos would be just flooded with light. The universe that we see as dark and mysterious would become a place of stunning clarity. The questions we could answer would be ones we currently consider to be pure philosophy, honestly beyond the reach of science. This colossal eye would change everything we know about astronomy. We would no longer be just looking at exoplanets, we would be mapping them. A telescope this large would have the resolution, the sharpness, to actually see details on the surfaces of the nearest exoplanets. We would not just be detecting the presence of an atmosphere, we would be seeing the weather within it. We could watch clouds drift across the face of a planet orbiting another star. We could see the difference between oceans and continents. We would see if a planet has polar ice caps that grow and shrink with the seasons. Think about that. We could make a weather report for a world light years away. We could watch for the glint of sunlight reflecting off a liquid surface, the telltale sign of an ocean. We could look for the green tint of widespread vegetation on a landmass. We would no longer be guessing if a planet is habitable. We would be seeing it. We would be creating atlases of other Earths. The search for life would transform from a statistical game of chance into a direct observation. We would simply look and see what is there. The universe, we believe, began with a Big Bang. For a while it was just dark, no stars, no galaxies, just this vast expanding cloud of hydrogen and helium gas. Then, after a few 100 million years, the very first stars began to ignite. These first stars were nothing like our Sun. They were giants, hundreds of times more massive, and they burned incredibly hot and bright. They lived for only a short time before exploding in spectacular supernovae. They were the forges that created the first heavy elements, the materials from which planets and even we ourselves are made. These first stars are a crucial missing piece of our cosmic story. The current Webb telescope is trying to find the light from the galaxies these stars formed, but it just can't see the individual stars themselves. They're too faint and too far away, honestly lost in the mists of time. But a telescope 100 times bigger could see them. With 10,000 times the light-gathering power, this giant instrument could collect the faint ancient light from a single individual star that lived and died over 13 billion years ago. We would be witnessing the moment the universe first lit up. We could see them flicker into existence one by one. We could count them. We could learn how massive they were and how they were distributed throughout the early cosmos. We could watch them explode and seed the universe with the first dust and metals. This is the cosmic dawn, the moment the lights came on. Seeing it directly would be like finding the very first chapter of a book we have only ever read from the middle. It would tell us where everything we see today actually came from. It would be the ultimate origin story. And beyond the first stars, what else might we see? Maybe we could detect the faint ripples in space-time, the gravitational waves from the collision of the first black holes that these giant stars left behind. Maybe we could even see the faint afterglow of the Big Bang itself, in more detail than ever before, searching for clues about those moments just after creation. With such a telescope, we would be peeling back the final layers of cosmic history, staring directly into the dawn of time itself. The darkness would finally give way to light. Our universe is honestly full of mysteries. One of the biggest is called dark matter. We know it's there because we can see its gravity. It pulls on stars and galaxies, making them move in ways they otherwise just wouldn't. It's a bit like seeing the branches of a tree being shaken, but not being able to see the wind itself. Dark matter makes up most of the matter in the universe, yet we've never actually seen it. It doesn't shine, it doesn't reflect light. It's completely invisible to our current telescopes. It's a ghost in the cosmic machine. A telescope 100 times larger might finally give us a way to actually see this invisible substance. While dark matter doesn't interact with light directly, it does bend the path of light with its gravity. This is called gravitational lensing. A very massive object, like a cluster of galaxies, can act like a magnifying glass, bending and distorting the light from objects behind it. A giant telescope could map this bending of light with incredible precision. It could create a detailed map of where the dark matter is, revealing its structure and how it clumps together. By mapping dark matter across the universe, we could start to understand its nature. Is it made of tiny, undiscovered particles? Does it behave in strange ways? These are some of the most fundamental questions in physics. A detailed map might show us that dark matter isn't perfectly smooth but has streams and clumps. It might reveal places where dark matter has interacted with itself in some way. We would no longer be studying dark matter by its vague influence on galaxies, but would be observing its detailed structure across the fabric of space-time. And what about dark energy? This is an even bigger mystery. It's the name we give to the force that's causing the expansion of the universe to speed up. It's a kind of anti-gravity, pushing everything apart. A telescope 100 times bigger could measure the distances to faraway supernovae with exquisite accuracy. By doing so, it could track the expansion history of the universe in fine detail. This could tell us if dark energy has always been constant or if it's changed over time. The answer would have profound implications for the ultimate fate of our universe. So here we are, at the end of our imaginary journey. We've travelled from a telescope just a little bigger than our own to a colossal eye on the sky that honestly seems like pure fantasy. We've imagined seeing the weather on other worlds and witnessing the very first star turn on. We've imagined mapping the invisible scaffolding of dark matter that holds the universe together. These are grand ideas, but they all spring from a very simple human trait, the desire to see a little more clearly, to know a little more about our home. A telescope 100 times the size of the James Webb would not just answer our current questions. Its greatest gift would be in revealing new questions that we can't yet even imagine. Every time we've built a bigger telescope, we've been surprised. We've found things we weren't looking for. We've been forced to rethink our place in the cosmos. A telescope of this power would undoubtedly do the same. It would show us a universe far stranger and more wonderful than we can currently conceive. It would be a humbling experience. To map another Earth, to see its oceans and continents, would remind us that our world is just one of many. To witness the dawn of time would connect us to the very beginning of everything. Such a telescope would be more than a scientific instrument. It would be a tool for perspective. It would change how we see ourselves and our place in this vast, beautiful, and endlessly fascinating universe. The journey of discovery, you see, never truly ends. The night sky is not empty. It's full of stories waiting to be read. We just need to build a large enough eye to read the pages. Each step, from our own eyes to Galileo's first telescope, to the James Webb and to the giants of our imagination, is another step on that wonderful journey. The quest for knowledge is a slow, patient and deeply rewarding one. And the cosmos has so many more secrets it's willing to share, if only we have the curiosity to look. I hope you enjoyed this journey through the cosmos. If you did, please consider liking this video and subscribing to Cosmic Discover for more stories about our amazing universe.